Now we want to draw something that is continuous and differentiable everywhere except for at x is 2. So at x is 2, we want to be sure to include something that makes it not continuous or not differentiable. So we could put a discontinuity, would make it discontinuous and definitely not differentiable there. We could put a cusp or a sharp corner there, or we could make it so that it looks like there's a vertical tangent. Probably the hardest option to draw of the three. Otherwise, we're going to follow just these explicit instructions below, and then we want to make sure that at x is 2, we're not differentiable or continuous. So our first thing we have is f of 2 equals -1, so we have a point to put on here. Here's the point x is 2, y is -1, so I've met that condition. Next, I want to make sure I am having a positive first derivative from -infinity to 2. So I want to draw something that is increasing. And then from 2 to infinity, I'm going to switch to being decreasing. That doesn't tell me too much because increasing and decreasing can look so many different ways, so I'm going to wait until I see what the second derivative is doing before I get an idea of what the picture looks like. So the second derivative for this is always negative, so it's always concave down. So I want to switch from increasing to decreasing and remain concave down. There are so many ways to draw this that would be correct. I'm just going to think about concave down, my 3 U's. I have the full upside down U, just the left side, just the right side. And I want to switch from increasing to decreasing while remaining concave down. So I want to be concave down before 2 and after 2. So it's kind of going to look like this full upside down U, right? It's going to be increasing to decreasing, but it's not throughout. It's everywhere except for at 2. So I can't be concave down here necessarily. So I want to kind of think about a few ways to do this. So I can make it look like a nice U like that. That's one option. I can make it look a little sharper if I want to. But one thing I'm thinking about is that parabola. Being concave down, but increasing at first. I don't have any points that I have to go through besides that one down there. So maybe I'm going to make it discontinuous at 2. That way it's definitely not continuous or differentiable there. So I'm going to put an open circle at the point 2, 2. And I'm going to draw something that's increasing and oriented downward, because I'm supposed to be increasing before 2, from -infinity to 2. And then I'm supposed to be decreasing after. And the whole time I'm supposed to look like I'm concave down. Before 2, it looks like I'm concave down, and after 2, it looks like I'm concave down. So there's one correct answer that satisfies all of these conditions. It goes to the points 2, -1, it's increasing, then it's decreasing, and it's oriented downward. But there are several correct options, especially when we get into these weird graphs where it's not necessarily continuous. You get a lot of freedom to do what you want.